Okay, welcome to ACT Prep Day 22. We are actually starting the algebra unit. So everything we've done prior to now would definitely be 8th grade and below, and some of this algebra you did have in 8th grade. So again, we're starting day 22. You should have your yellow sheet of paper for your bell ringer. You've got 3 questions talking about the circumference of a circle. So you've got to make sure you know your formulas for circumference and area of a circle. And pause the video, take about 5 to 10 minutes to do the bell ringer. And when you're finished, unpause and we will go over the answers. Okay, welcome back. And if we look here, when we have the circumference, we can either use the circumference or the radius in the formula, because 2 times the radius is the same thing as the diameter. So pretty much if the diameter is 16 feet, you just got to slap a pi on it. 16 pi feet. It's linear units, so there's no exponent. For the area, if we're using the same diameter, we have to cut the diameter in half. We have to have the radius for area. So if the diameter is 16 feet, the radius is 8. So that is pi r squared. And 8 squared is 64 times pi. Slap that pi on there. And remember, it's in square units, and units matter. Now, this was one of your exit tickets. I should be able to give you the area of a circle or the perimeter or the circumference of a circle, and you should be able to calculate what the radius is. So here, you have the area is 30.25 pi. We know the formula is pi r squared. So I can divide, let me change the pen color so you can tell what I'm doing. I can divide both sides by pi. If you've got a calculator, well, technically you don't need a calculator, sorry, because pi divided by pi cancels. So now you've got 30.25 equals r squared. Take the square root of 30.25, you get the radius is 5.5. Now, if they want the circumference, all you needed was the radius. 2 times 5.5, which is 11, times pi, slap that pi on the 11, and circumference is 11 pi inches. Yep. So today we're going to evaluate expressions and we're going to write expressions. Now, there's a big difference between an expression and an equation. And the big difference is expressions don't have an equal sign, and an equation does. That's why we call it an equation. Equal. Yeah. So you cannot solve an expression. There's no way to solve it for the variable. You basically just have this expression and there's a variable, and when you tell me what the variable is, then I can evaluate it. But you've got to give me the value of the variable first, okay? So, like here, technically this is an equation, because we got an equal sign here, but because you're giving me the value of the variables, I can solve for v. Okay, technically we're solving this equation. We're evaluating each one of these individual expressions, so I can evaluate this expression and this expression, tell you what they are since you're telling me what t is. So this expression, 2 times 5 is now going to be 10. This expression, 5 times 1 is going to be 5. So I can evaluate these. Now I can solve this equation for v. I wouldn't have done it this way. I'd have plugged my numbers in like I just did. Then I'd have combined, moved everything over. I would have gotten 3v is equal to, what is that? -2 minus 10, -12. So v is equal to -4. Now let's make sure I didn't mess it up. Oh, no, I did it right. Did a lot of that in my head. And again, sometimes the book, like, they just really made that math complicated. There's no need to overcomplicate it if you don't have to. That's why you want to practice. You want to practice and get your own method for solving these things. Because again, sometimes when you work the problems the way the book tells you, you're going to look at it and go, like that one, that's silly. Why do I need to do it like that? That's making it hard. Why can't I just plug in the values here and solve for V like Edwards just did? How can you check this question? Well, I can take this answer, plug it back in here with the other two, and see if it's equal. You might have questions that include solving for a particular variable. And this is one that students, I find, really struggle with. And it's perplexed me as to why students struggle with this. Here is the equation for kinetic energy, and it's K equals 1/2 mv squared. And they basically want you to solve for mass, so they want you to rearrange this equation to where it's m equals. And students usually look at me and they're like, I have no idea how to do this. You do. Because if you know how to take a linear equation and get it in y equals mx plus b form, which you've been doing, that's what this is. You were solving for y. And pretty much what you did was you rearranged the equation so y was over here by itself and everything else was on the other side of the equal sign. So that's what you want to do here is you want to rearrange this equation where m is on this side and everything else is on this side of the equal sign. So it's just like a linear equation when you're solving for y. And you can see when it's m, the equation changes. This happens a lot, especially if you go into banking, finance, because you've got all these formulas for compound interest. And, you know, if you go in for like an IRA or somebody says, hey, you know, I've got $20,000, I want to invest it. How long do I need to leave it in? You're going to be able to tell them how long, how much money they'll have at the end. But maybe I sit down and I'm trying to plan my retirement. Hey, I want to have $2 million when I'm 65. They're going to backtrack based on how many years I have left till I'm 65, which I'd have to put down more money than you would because you're younger. You have more years. What the interest rate is, and then they're going to be able to say, I need you to put down this much money now if you want to have $2 million by the time you're 65. So you've got to rearrange that equation. Here you might have, oh, this is that one, it's here. This is union. Sorry, it shows up as smiley face sometimes. So this is where we do the union. So we're trying to put these two vectors together, and pretty much this is where we're doing the outside numbers, outside and inside. I don't know why. I like to think of it as it's a U and a U. Yeah. So this is going to end up being, okay, T times N outside U plus inside U. So that's going to give us 11. 3 times 2 plus, let me erase my pen, 5 times 1, which is going to give us 11. Yeah, see, I told you they put a smiley face in there. You need to know how to convert a word problem into an algebraic expression. So that's going to be your keywords. You've got to know that sum means add, difference means subtract, product means multiply, quotient means divide. Here's an example, 3 more than twice a number. And I'm going to be real with you, these are hard. These are really hard when they give you these for one of two reasons. You know, one, they're just hard. They're just hard. You only see it in a math class. 2, we don't talk like this. I never in the outside world or in business went to someone and said, you know, I need you to order 3 more than twice 5 units for me. Never did that. And even still, I'd be like, okay, I got 5 here. I need you to give me, double that plus 3. So, that's pretty much what it would be is, hey, double that. I got 5. I need double that plus 3. So what's that? Okay, I need 8 more. I do direct translation with this because I really get confused myself. Numbers direct translate to numbers. When I get more than, this is a plus. Twice, that's going to be 2 times. And then a number is a variable. So this expression is 3 plus 2n, 3 plus 2x, 3 plus 2a, whatever you want to call it. This one's a little bit more difficult. I'm going to do direct translation. 8 less than 3 times, difference means subtraction, between a number and 1 is always equals 7. Hopefully you followed me there. I went straight how it was written. Now I'm going back and I'm looking at it going, oh, that does not look like a math equation at all. At all. So now I go back and I kind of look at it and I'm like, okay, you can't do a multiplication then a minus. So 8 less than 3 times the difference between a number and 1. Okay, so this needs to go here. So this really needs to be n minus 1. Got that figured out. 3 times the difference. Oh, and this is where I usually mess it up. So we've got distributive property here. And I've done this enough times that when I get 2 orders of operation side by side in direct translation, that's telling me that I'm going to be using the distributive property. Now, anytime you have a minus or division, you've got to really, really analyze it because, again, I can do 2 plus 3 and 3 plus 2, I'm going to get the same thing. But 2 minus 3 and 3 minus 2 is completely different. So I've got to make sure, is it 8 minus or is it minus 8? It's 8 less than whatever this is. So the minus needs to come here. Once I do 3 times n minus 1, then I subtract 8, then that equals 7. Like I said, those are kind of hard. I always had problems when I got to that and had to really work problems and figure out a way to get the correct answer. Again, I don't find these fun at all. I don't. It's common to see a fixed and variable rate question on the ACT. So there's many examples of real world costs that can be used in this type of a question. Here we go. You've got Julia sells cookies at a concession stand. She's got fixed costs. She bought a bowl and she bought a mixer to start her business. That was $30. She's got a variable cost of 30 cents per cookie for the ingredients. So she wants to have an equation to represent what her profit's going to be. And she's going to sell each cookie for $2. So you would go, our variable costs are 30 cents per cookie. She's got to absorb that $30 in fixed costs for the mixer and the bowl. And that should be equal to $2 per cookie. Okay. Now you should be able to move this over and you're going to end up getting, oh, no, I did that wrong. Oh, I'm kind of right, kind of wrong. Sorry. So her profit is $2 times the number of cookies. Ew, I don't know. Let me erase that because I got to do a minus in there first. Minus her expenses, which are the 30 cents per cookie and the $30 for the mixers, and that's going to equal her profit. So 2 minus 30 cents, she's making a profit of $1.70 per cookie. And then once she makes $1.70 per cookie, she's got to subtract out the $30, that fixed cost, and that's going to give her her total profit. So basically, she's got to make $30 before she gets any profit. But once she's paid for the bowl and the mixer, she didn't have to pay for them again. So our ACT example, pause the video real quick. See how well you do on your own. Again, if you can't do it, do your guess answer, then unpause and let's see how you did. Okay, now you're back. Let's check and see how this answer is. Here we've got real numbers x and y, such that the product multiplication of y and 4 is x. So you multiply 4 and y, so 4 times y equals x. Which of the following expression represents the sum of y plus 4 in terms of x? So when it says in terms of x, that means we want to get rid of the y's and have x's in there. How do we do that here? Well, we need to solve for y. Y is going to be equal to, divide both sides by 4, y will be equal to x divided by 4. Whatever x is, divided by 4, that's going to tell you what y is. So now I can take this and substitute it in here for y. So if we want this answer in terms of x, it's going to be whatever x is divided by 4 plus 4. And that answer is B. Okay, 6 questions. Set your watch, set your phone, set whatever timer you've got. Work on these 6 questions, hit pause, and when you're done, get back to me. Okay, welcome back. Let's check our answers and see how you did on these. And so the first one, here we've got this equation, 4x plus 8y. Which of the following represents x in terms of y? So what this is asking you to do is rearrange this equation. Instead of y equals, they want it to be x equals. Okay, that's what you're doing. Same thing you've been doing in algebra. So you have 4x equals, plus 8y equals 16. So what you're wanting to do is you're wanting to isolate this x here. You want to get it by itself. So in order to do that, we need to get rid of this 8y over here. We need to move it to the other side. So now we've got, 4x is equal to negative 8y minus 16. Now to get x by itself, divide both sides by 4. That cancel. Divide this side by 4. So now we get x is equal to negative 2y minus 4. Oh, because that's a plus 16. What am I thinking of? Yeah, that's why you got to be really good with your writing and not be sloppy. So the answer is C. And luckily that bad answer wasn't on there, and it kind of caught my mistake, made me look back at my work, and I saw where I made my mistake. This is another reason why it's good to write out all your steps, because I was able to easily go back and catch where I made my mistake. The next one, we have got if x plus 2x equals 20, then what's 3x? We just need to take this equation and solve for x. So x plus 2x equals 20. We're going to subtract 8 from both sides. And you get 2x equals 12. Divide both sides by 2. And you get x is equal to 6. Now be careful because 6 is an answer. It doesn't want what x is, it wants what 3x is. So what's 3 times 6? 18. 18 is your correct answer. Here's another one of those problems where they just give you abstract numbers and they don't tell you. Well, again, I'm going to pick something. When t is equal to u squared, which of the following expressions is equivalent to negative t? Again, you can pick numbers. I'm probably going to go through here and go through the answers, okay? So if I have a u, that ain't going to be it. 1, u to the negative 2 is going to be 1 over u squared. That ain't going to work. Negative u, that's not going to work because I got to have u squared. Got to be u squared somewhere in there. This one is not it. No. This, students get this messed up a lot of times. This is u squared times negative 1. That's not going to give you negative t. Oh, sorry, it is. Oh, I just messed up. No, this one is the one that's going to be the answer. Should be yes. Told you I'm going to mess up one time. This one is not, because negative u times negative u is going to give you positive u squared. Okay? Negative u times negative u gives you positive u squared. So that's just t. This one is negative 1 times u squared, which would give you negative 1 times t, which is negative t. So our answer is G. Sorry, got going a little too fast there. Here, this is a real world problem. I've had this before in business when I'm renting a car. The company I'm working for will give me an allowance for a rental car, and so I do try to figure out, how much I can drive before it's on my dime. So here you've got $65 a day fixed cost, 33 cents per mile. So what is going to be the total cost? So that's pretty much going to be 65. Oh, that should be an equal sign. Sorry. That looks like a not equal sign. $65 times however many days you have it, plus 33 cents per mile. That's going to be your cost. And you can see that answer is represented in D. Here you've got another one. The home team score exceeded 2 times the visiting score by 5. So if the visiting team score is X, then the home team score was 2X plus 5. Yeah. And here's the last one. John has 76 marbles that are either blue, green, or red. He finds that there are 34 more red marbles than green. So we have red marbles in terms of green. 12 more green marbles than blue. So now we have green in terms of blue. So let's let X be equal to blue. So now green is going to be equal to, there's 12 more green marbles than blue. So if blue is X, green is going to be however many blue ones there are plus 12. So the red one is there's 34 more marbles than green. Well, if green is X plus 2, or sorry, X plus 12, then there's going to be 34 more than that. So now I can add all 3 of these together and get an equation that should equal 76. So I'm going to get X, that's my blue marbles, plus my green marbles, which is X plus 12. Now my number of red marbles, I'm going to do 12 plus 34 is going to give me 46. So it's whatever x plus 46. And that should equal 76. Now let's simplify it. I'm going to go up here. We get 3x plus, what is that, 58 equals 76. 3x equals 76 minus 58. What is that going to give me? Is that going to give me 18? So x is equal to 6. So that tells me there's 6 blue. There's 6 blue. Green is going to be 6 plus 12. So there's 18. And red is however many green plus 34. So 18 plus 34 gives me what? 52. Yeah, that one's a little complicated. That one takes a little bit, I have to admit. That's probably the hardest one we've done in a while. Yeah, that one really is. So take your exit ticket. Now this one, I get a lot of zeros on this one. I do. Again, if you don't know how to do it, you take a screenshot, send it to me on Google Classroom, send me an email, ask if you're on the right track. Here you have got to figure out how many widgets in an hour machine A produces. Excuse me. How many widgets in an hour machine B produces in an hour. Then you've got to figure out, you got to combine them, how many does machine A and B produce in an hour. Now you've got how many both machines produce in 1 hour. You got a formula for that. Now they want to know, if you keep both those machines running, how many are they going to produce in 6.5 hours? So again, find out how many machine A produces, how many machine B produces in an hour. You got to add those together to find out how many both of them produce in an hour. Then you got to take that number and figure it out for 6.5 hours. So again, if you're unsure, do not get a zero. Take a picture, send it to me. Miss Edwards, am I on the right track? Let me help you. Okay, happy mathing, and I'll see you next time.